All right, so we're going to look at number 13, and if you look up at the top of the page, you'll see that we've got that box y equals CE to the KT and what everything represents. Okay, so looking at number 13 says, after 1 hour, whoops, forgot my pen. Okay, here we go. After 1 hour, there are 150 bacteria, and we're starting initially with 25. So let's start by doing 150 equals 25. E to the, we don't know what K is, but we know the time is, oops, sorry, it's not that, it is 1 hour. Okay, so let's divide out the 25, which is going to give me 6, equals E to the K. And then remember, if you want to get rid of an E, we just ln. So I'm going to ln the 6. I'm going to drop that K down, and I'm going to ln the E, which remember is 1, so that cancels out. Okay, so there's our K value. Now what they want us to do is, how many bacteria will be present in 2 hours? Well, how many is an amount? We have an initial amount of 25. E to the, we know what K is, it's ln of 6, and it says in 2 hours. So time is 2. So now all you have to do is just put all of this into your calculator and get a numerical value. Okay, so when you do that, I get y equals 900, and that would be 900 bacteria. Okay, I'm going to abbreviate, I'm lazy. So there's your answer to part A. All right, let's look at part B. It says, how long will it be when there are 10,000 bacteria? So they gave you an amount, and that amount is 10,000. So we're going to do 10,000 equals 25 E to the, and we know that K is what, the ln of 6? And we want to know what the time is, so that we don't know. Okay, so we're going to divide that 25 out, just like we did in part A. And that's going to give us 400 equals E to the ln of 6, that value times T. Okay, then I'm going to ln both my bases. So I'm going to ln the 400, and I'm going to ln this E, which will cancel that out, right? Okay, so I'm going to get the ln of 400. Remember, on the right-hand side, the ln and the E are going to cancel each other out. So that's going to leave me with ln of 6, that value, times T. So to find time, just divide by the ln of 6. That will make that disappear, and then we can just plug in your calculator ln of 400 divided by the ln of 6. Okay, and when I do that, I get T equals 3.3439. Now, it doesn't tell you what to round it to. Usually it will, but it doesn't. So I'm going to leave it because I like to go 4 places past that decimal. But the time would be hours. Okay, so if you read this question, it doesn't give you an initial amount. Okay, when it doesn't give you an initial amount, you can really make up any number. I tend to use 100, and I'll explain why. So we're using y equals CE to the KT, right? So y equals CE to the KT. And again, they didn't give you an initial amount. And the reason why I like to use 100 is this, because then it says there's 75% present. So 75% of that 100 is easy to do when it's 100. Like if you pick 2, 75% of 2, and then to do that in your head is more difficult. But I know 75% of 100 is just 75. Okay, so 100's like a nice, easy number. Okay, all right, so we don't know what the K is, but we know that the time is 2,500 years. So let's just solve. So we are going to divide by 100, which is going to give us 0.75, equals, oops, I think I dropped my E there, e to the 2500k. Okay, let's ln both bases, so I'm going to get the ln of 0.75. Now remember, ln of e, that's going to be a 1, so I'm not going to write it. And this is 2500k, and then just divide by 2500. Okay, so there's your k value. It doesn't answer the question, but we need that to answer the question. Okay, now, they want to know what is the half-life. Well, half-life means whatever your start amount is, after a certain period of time, you should end up with half of that. Okay? And then we're going to do e to the, now I didn't write what the k was, but hopefully you realize that it's the ln of 0.75 over 2500. Okay, so then I'm going to put that in right here. So e to the ln of 0.75 over 2500. And they're looking for time, right? We want to know what that time value is. Okay, so I'm going to divide out the 100, which is going to give me 0.5, equals e to the ln of 0.75 over 2500, and multiply that by t. I'm going to ln both these bases, and that e will cancel out. So I'm going to have the ln of 0.5 equals the ln of 0.75 over 2500 t. So to get t by itself, you have two choices. I could divide out this fraction, or I could multiply by the reciprocal over here, which is what I prefer to do. Okay, so I'm going to take that fraction and I'm going to flip it. So I'm going to be doing 2500 over the ln of 0.75. Okay, and the same thing over here, which would make that disappear. Okay, and then all you're going to do is just put this in your calculator. Multiply these two guys, get an answer, and then divide by that. Okay, so I ended up with t equals 6023, so 6023.5520, and that would be years. So that would be your half-life. All right, so take a moment and read number 15. Pause me if you need to. Okay, so they're talking about there were about 600 million computers in use in 2001. So that's your starting point. So that's going to be your C, 600. Then they're saying that the number was increasing at an annual rate of about 10%. So that gives us our constant of proportionality. And 10% as a decimal would be 0.1. Time is going from 2001 to 2010. So all you need to do is subtract those, and we know that that's a time of 9 years. And they want an amount. So you just put that in your calculator, and you're going to get 1,475, but don't forget that this is all in millions. So you can just write the word million next to it. 16 is one of those questions, and take a moment and read. And guys, please make sure you're taking notes in your packet. 16 is one of those questions, though, where they don't give you an original amount. So if they don't give you an original amount, and you're doing y equals ce to the kt, just remember I like to use 100 because I think it's easier. Now, if you keep reading, it says the paint contained 12% of the original amount. So 12% of 100 is just 12, and that's why I like to use 100 because it's pretty easy. And then we're going to multiply that by E. Now they gave us the K, and we are decaying though. So when you put in the K, make sure that you have a negative there. And then it's 0.000, right? That's 3 zeros, 1, 2, 1. And times T. Okay, so, well, we have an exponent, and and we don't know one of the values in that exponent. So I want to try to get that by itself. So I'm going to start by dividing out the 100. And that's going to give me 0.12 equals e to the negative 0.000121 t. You see an e, so remember, we're going to ln then, and that will cancel that out because the ln of e is just a 1. So we have the ln of 0.12 equals negative 0.000121 times t. And then I can just divide that out, negative 0.000121, and same thing over here. And that's going to cross that out. And then you just throw that into your calculator. And you will end up with t being 17,522. Now, it doesn't tell me what to round to, so I'm going out 4 places past that decimal. 0.8391, and the unit is years. Okay. Alrighty, so if we turn the page, and we are on page 12, and again, we're going to use y equals ce to the kt. The initial amount that they gave you is 175, and we have an end amount that they want us to reach of 315. E, our constant of proportionality is an annual rate of 12%, so as a decimal, that's 0.12, and they want to know how long, which stands for time. So similar to the last question that we just did, we're going to divide out the 175, and no need to simplify that. That's what we got a calculator for. But I do notice that I have an e, and I have an exponent that I don't know. So I am going to take this, and I'm going to ln that side, and I'm going to take this, and I'm going to squeeze in an ln there. And remember, that will cancel out the e, because the ln of e is 1. So on the left here, I'm going to have the ln of 315 over 175, sorry about that. And then over here on the right, I'm just going to have 0.12 times t. And, well, then from there, we're just going to divide out that 0.12 and just throw this in your calculator. Don't forget to use alpha y equals, and you will get 4.8982, and the time unit is years. Number 18, please read that one carefully. The second sentence really starts us off with saying that the colony starts with 1 bacterium. So if I write y equals ce to the kt, what they just gave me was my c. And it says that it doubles every half hour. So doubles would mean the y would be 2. Don't have the k, but the time is half hour. So half hour, I'm going to put in 0.5. Now, this does not answer the question that's in the third sentence, but we need to find the k first before we can answer that question. All right, well, obviously I could divide out the 1, but we know that that's really just going to be 2 equals e to the 0.5k. And then from there, I have an exponent that I don't know, and I have an e as a base, so I'm going to ln both of these bases. And the ln of e is 1, so then I just have the ln of 2 equals 0.5 times k. To solve for k, I'm going to divide by 0.5. So my k is the ln of 2 over 0.5. Now that's not what they asked for, but I need that to actually answer the question. So the question asks in this last sentence right here, how many, which means y, will we have? And we know the original amount is 1, e to the k. Now we know that the k is ln of 2 over 0.5 times the time, and it says 24 hours at the end of 24 hours. So I'm going to multiply that by 24. All right, well, at this point, this should be pretty easy because all you're going to do is just take this and you're going to throw that into your calculator and see what you get for your y value. All right, so I've got something really crazy. I have 2.8147. Oof. And let me see if I can rewrite that because that looks gross. And you know what? It looks even grosser. I'm going to write it down here so I have more room. So I have y equals 2.8147. Then you should see an e in your calculator, and that means times 10 to the, and then look at the number right after the e. That should be a 14. So that's exponential. It's like scientific notation, sorry. That's the way that your calculator shows scientific notation. So whenever you see an e, that means times 10 to the. And then the power that it would be raised to would be the number that comes to the right of the word of the letter e. Okay, this question isn't hard, but we really haven't seen one like this. When it says to find a model of f, basically all that wants is an equation. And it just wants an equation, but we do want to make sure that we find our k. So let's read the first sentence, and we're going to start again with y equals ce to the kt. Your initial amount is going to be 100. We don't have the k, and it says it triples every hour. So that means that the t is 1. And it triples, so that means our y is 300. So I'm going to divide out the 100, and that's going to give me 3 equals e to the k. All right, well, just like all the other ones, I have an e, and I have an exponent that I need to figure out, so the way I can drop that down in front is by ln'ing. And that's going to drop that k down. So then I have the ln of 3 equals k. All right, so it says find a model f that models the amount of bacteria after t years. So that means f of t equals our initial amount, which is 100, e, our k, which is the ln of 3, and technically that's times t. All right, and that's the answer.